Hi, Harmeet. Welcome to Career Chat with Raji. How are you?
Yeah, hi Raji, I'm good. How are
Good.
you?
I'm good. Thank you. It's so nice to meet you here. And I'm so glad you can come here and talk to us. For anyone who's listening, we are going to talk about AI, ML, data engineering, data scientists. What are the differences? Because our guest here, Harmeet, is a data engineer. She works with ThoughtWork. She's been in Melbourne since 2017. And I think I'll hand it over to Harmeet so that she can tell us a little about herself.
Yeah, thanks, Raji. Hello, everyone. I'm Harmeet, and as Raji mentioned, I work at ThoughtWorks right now. I'm a lead data engineer at ThoughtWorks. So what I do at ThoughtWorks is I work with various clients to design and implement data applications and machine learning solutions as well. So that's my core work. But apart from that, whenever I have time, I try to share my failures through conference speaking, my blogs, whatever my learnings are. And internally at ThoughtWorks, I also am leading a practice where we're trying to compile all the practices and matured practices of implementing or designing a data platform. And I am a co-host of Data Engineering Melbourne Meetup as well. We have around 4,000 plus members. We were able to survive during the COVID time, so yeah, looking forward to have the meetup in the real world, face to face. And that's my professional life, and I'm a mom. I have two kids, one calm and one naughty kid. So yeah, that's me, Raji.
Oh, that's awesome. That's a very interesting bio, Harmeet. I didn't know you did blogs and meetups. If you at the end of it, if you can share the links with us, I'll attach it to this video so that anyone who's listening and wants to know more about your blog and what you do in the meetups, they can have a look at it. All right. So we have some interesting questions. I have some interesting questions, and I think these questions around the artificial intelligence, machine learning space, there's some sort of confusion for people who actually don't work in that space very closely. So I have these questions here. So let's start with basic, like this is for me also, right? And I think a lot of us would want to know these questions. The difference between AI, machine learning, data engineering, and data scientists. What is the difference?
Okay. Okay, let me start from AI. So the name AI, when we expand it, it says artificial intelligence. So human beings and animals are like have natural intelligence. There is something in our brains which probably till now doctors understand a bit, but still I think there's not complete understanding. So that's a natural intelligence. Now there are machines built by humans, right? So any intelligence that is demonstrated by machines is artificial intelligence. Like we are switching on and off light, or maybe face recognition, which is like being used today, fingerprint recognition, identifying a person. That's all artificial intelligence. If something is identified by machine is like uh, artificial intelligence. So that's like a high level, definition of artificial intelligence. Now, there are a lot of blogs. I think people who want to go deep into AI, I would recommend like watching videos, blogs. There are enough information. I don't want to make it a class for AI, but that's a high level definition. Now, coming to your second uh, uh, point of machine learning. Now, again, I'll go by the name itself, machine learning. So machine learning is when you're teaching machine to be intelligent. Now, the machine learning, when we are saying teaching, how are we teaching? We are feeding lots of past data to the machine and telling the machine to identify some correlation or um, create its own program based on the past data. So we are not essentially doing any sort of programming, but we are supplying the past data, historical data to the machine and telling it to find out the correlation and act accordingly. So teaching machine to learn on based on data is machine learning. That's a super high level definition. Does
Right.
that make sense?
Yeah, that makes sense.
Okay. Now, AI, ML, and I think third thing you asked was data engineering. So, okay. So now for machine learning, or maybe, not just machine learning, we create a lot of reports, right? Business insights. We need a lot of data. Now, data is in different forms, scattered all around the world, all around the applications, and you may need a lot of data for the insights, for teaching the machine to learn, right? So how do you get their data? So you need to first get the data, change into a format that machine can understand. Now, what can machine understand? It can understand numbers, right? So you have to convert that whole data into a different format, which machine can understand and then feed into. So that's the core thing that data engineers do. But apart from this, data engineers also design systems which can run those pipelines, which convert the data, feed to machine learning, feed to those machines, and train those machines again and again so that they can keep learning. So the complete end-to-end designing of that system, where data starts from the raw point or collection point and reaches to the machine where the machine can be trained. It's all the work that data engineers do.
Right. Okay.
Okay. Now let's come to the data scientist.
Yeah.
What do data scientists do? So I think I feel that based on what I've heard from people, there's a lot of confusion around data engineering and data science as well. Now, for me, there can be different definitions, but I feel that what I understand, data scientists are basically mathematicians, statisticians, who understand, who can teach machines. Now, I'll give you a very simple example of what machine learning is. So behind the scene, it is nothing but finding an equation. So creating an equation. Now, there can be various ways of, there are various ways of creating an equation. So machine would do that, but then statisticians who have understanding of calculus, probabilities, optimization, they can work with those machines to find out what is the best way they can learn. The machines can learn. So you need to have an understanding of statistics. So what they do is they take that data, find out because behind the scenes, machine only understands numbers. So what we take that data that data engineers have created in a specific format, but then how do you convert that data into correlated numbers so that machine can learn, is what data scientists do.
Right. Okay.
They have to understand. I think only if you don't understand maths well, I think there would be a problem, or maybe you cannot be a very good data scientist. That may be like sort of a pre-notion from my side, but that's what I've learned. You have to be a good statistician. You have to be good at maths to be a good data scientist.
So do data engineers and data scientists work together for machine learning? Yes. Okay.
Yes, absolutely. So the skill set of data engineers is to allow, so data scientists may not be able to design systems which can scale, design systems which can transform data in like high volume of data, or maybe high variety of data, right? A high frequency. I mean, there can be different frequency at which you may need data. So that's where data engineers work with data scientists, and together they design a system, they train a machine to learn, or maybe, it's not that just data scientists, but they may work with data analysts as well, who may not be teaching a machine, but just be analyzing data to, create some sort of business insights, right? So data engineers get data for the data analyst and data scientist.
Oh, interesting. So I'm just like, when you started speaking, I realized, artificial intelligence, machine learning sort of has a, if you know English, it probably does make sense. But from what I have heard, understood speaking with other people in our industry, there's this confusion exists. Why do you think that this confusion exists around what is the difference between engineer, scientist, analyst, machine learning, artificial intelligence, and how can we create more awareness around it?
Yeah, that's actually an interesting question. Let me think. I think the first point which I can think of is this field is still evolving. So right now, we are at a point where software engineering was like 20 years or 15 years before, 15, 20 years before. So that's where the data field is right now. So it's still evolving. There's a lot of confusion. Even, I mean, it's not just about individuals. As a consultant, I have seen that confusion in the organizations as well. So yeah, the first point is like there's still organizations are trying to figure out what do they need, what are the problems they want to solve. So first of all, they were not even aware that there are problems that they can solve with data. So now they know that there are problems that can be solved by analyzing or teaching machines or analyzing data and so on. So once they realize, they thought, okay, we need someone who can like analyze the data or teach the machine. So they hired like some people who understand machine learning or data science. But then once they realized, when they hire data scientists, the data scientists started asking for data, right?
Right.
And then
Yeah.
they realized, oh my god, data scientists, they understand stats and all those things, but they don't have the skill set to get the data, format the data, or scale the system. So what do we need? Then this data engineering field emerged. So once this emerged and started evolving, so there is still like organizations are trying to understand that what they need, and these new occupations are emerging because of the needs of the organizations. So one thing is it's still evolving. The second thing, again, this is my personal opinion is that people just think about cool stuff. They just look at the cool stuff where they say, oh my god, take some data, give it to machine, they'll learn. And there is like a lot of things in between the whole journey that the data has to go through to reach to the machine. And there are different type of skill set that are required. So I think if somebody wants, there's a lot of material available again in the on the internet as form of blogs and videos. It's just that trying to understand, and maybe as the organization, it takes me to my first point. As people evolve and understand more about the problems and what they want to solve, they'll get more awareness. But awareness would only come with experience or by trying to read those blogs, read those articles, or read those videos, and not get bogged down by the cool stuff, data and machine. Oh my god, I want to teach machine to learn, that's so cool, just put some data, and that's how we go.
What are the sort of skill sets that distinguishes a data engineer from other engineers? So for example, if I'm a developer, I need to know some tech. I'll be a Node.js developer or a Java developer. It's interchangeable, but that's the sort of skill set I need to have. What is the skill set that distinguishes a data engineer?
Yeah, so that's a very, very good question, actually. And in my opinion, if we specifically talk about data engineers, they should be software engineers. I mean, software engineering fundamentals are really, really important. And working in this field for some time, I realized that there is a huge lack of basic principles. So I have seen organizations doing cool machine learning or maybe formatting data. But I have also, like in the same organizations, I've seen, this is a very bad example, but I've seen that those cool data engineers and data scientists are not even using Git versioning. I mean, Git as like, it's a very, very bad example. So that's that's basically, a fundamental version control. The
Yeah.
CI/CD pipeline. So I have seen that data engineers and data scientists are not aware of, basics of CI/CD, the automation testing, like TDD. All those software engineering principles are still valid for data engineering. So my first, uh, uh, 2 cents for anyone who wants to be a data engineer, or the skill set, as you said, is it should be a software engineer. Now, on top of that,
Yeah.
so if you are a software engineer, you can become a data engineer. That is not a rocket science. But if you are just like worked on cool data stuff, but don't know the software engineering principles, the basic core engineering principles, I would recommend, doing some reading on that. So on top of software engineering principles, there are some basic data uh, platform, or data frameworks that we should understand, because in any sort of data platform, or even a machine learning platform or anything, there are certain key things: that you ingest data, you transform data, and then the data is ready for consumption. So there could be different ways uh, and gotchas while you're ingesting the data. There could be different formats of data. There could be different frequency at you would want to ingest. So you have to have an understanding of the problems, or maybe some sort of frameworks. Tools is, every day we are getting new tools and techs. I think it doesn't matter if you have basic, like if you worked on just one tool to ingest the data, you have understand the one tool, it's fine. But understanding the problems in the ingestion side, or what are the frameworks that we should be using, like who should be owning the ingestion? Should it be the people who are transforming the data, they should be ingesting the data, or people who are actually own the raw data, or actually understand the raw data, should own the ingestion? So this is just one example. So understanding those frameworks of ingestion. Now when we are transforming the data, what are the basic principles of transforming the data? So there are various tools available. You can do transformation through Spark, you can write SQL queries, you can use warehouses like Snowflake is very popular, Databricks is very popular, there is Spark clusters which are very popular. So again, understanding like distributing processing is important, because when we are talking about transformation of data, it's like normally it's big data, right? So there would be scale that would be important when you're transforming the data. So if you have an understanding of distributed processing, that will be like critical on top of like software engineering, and then ingestion, and then transfer. And when we do transformation, the other thing is the orchestration, right? So your data is coming into the system, it is going through different journey, it may be transformed into different forms, right? Different layers of transformation, in one form, then the second form, maybe more mature form. So you clean the raw data. Then once you've cleaned the raw data, it's more into like application or technical terms. So you change into business terms. And once it is in business term, then you create a data product out of that cleaned up and business transformed data, right? So so there should be some sort of visual orchestration where we should be able to see how the data is traveling. There should be a lineage that you should understand, because if you can't see or track the lineage of data, and you have as the pipeline start increasing, it will be a mess. So understanding orchestration and lineage is really important. So apart from this, having like understanding data observability is really important. So again, what I'm saying is on top of software engineering.
Right.
So
Yeah.
observability in terms of software engineering, it's still there. Now, on top of that, logging, monitoring, and alerting, we need to understand data observability as well. Now, what do I mean by data observability is understanding that you have certain assumptions about the data, that your 90% of the data should not be null. Again, it's a business, like you have to work with the business to understand. Now, if that is not true, do you have certain observability in your pipelines or data transformation journey to assert, so that it's not a silent failure, because data goes into the right to the business end, and somebody business would see, and then they'll realize, okay, I can't trust this data because this is not right. So idea is to have those validation or data observability or data tests in the left, so that there are no silent failures. They can be, it can start from simple nulls, but then it can be as complex as checking the distribution of data, checking the general sales figure. For example, every day the revenue of a company is, maybe, let's hypothetically, it's 100,000, right?
Yes.
Some $100,000, but suddenly, the surge is like maybe 500,000. Or maybe it's like a range between 100 and 200, but suddenly you're getting 500. So either it's an expected behavior, or there is some problem in the system. So do you have those that sort of observability in your system, right?
Wow.
So that is very, very critical for a data engineer to actually work with the business and implement that observability. So this is observability, and these days it's like becoming better and better. People have like trying to understand and realize that we need more observability. Apart from this, when we go towards the right side, the consumption pattern. When I say right side, the way I think is left is an ingestion, center is a transformation, right side is a consumption, where you consume the data products, right? And data products can be machine learning products, or any sort of insight, can be anything. So we call it as data products, right? So at the consumption side, what kind of consumption patterns can be there? So it can be traditional, APIs, but can be dashboards. It can be something else. So understanding those consumption patterns and asking the right questions about the consumption patterns is really important. Also, when we are talking about consumption pattern, it's not just about like the dashboard or the machine learning or the API. We also have to understand what is the need. Like, is it a real-time need, or is it a batch need? And gradually, I think everything would in future would go to real time. But the question again we should ask is the real time need actual need, or it's just like something we want to do fancy? Yeah. Because ultimately, the product thinking and agile thinking is also applicable in data products. So think about thin slicing, what you can quickly do, prove the value, come back and enhance it. So don't try to do. So again, I mean, I'm of the opinion that, yeah, everything would be real time in future. But this example I'm giving about real time and batch may be easy to do, but sometimes, people may think real time is cool, so let's do it, but it may take a while. So think about the needs, what you can deliver as a vertical, thin slice, then come back and enhance based on your needs. So the product thinking, software engineering, those are still applicable on top of, what I mentioned about those other principles.
So you just mentioned that there are three phases, right? Or sort of three phases that you split into. Is data engineering the same across the three, or do you need like a different mindset and different engineering skills for these three phases?
Yeah. Again, that's a very good question, because I can like probably write thesis on this, but let's see if I can.
Maybe you should.
Yeah, sure. If I hopefully, one day if I get time. So that's actually, I have seen in my past experience. So there are various skills which would be required in all three sides. And so when we are talking about, let's say, ingestion, right? So ingestion, there may be, again, I'm taking a specific example, Kafka, right? So Kafka is, so in Kafka, you may be creating, some sort of streams of data. So Kafka is, those who don't know or have not had a chance to work in, Kafka is very popular these days as an ingestion, event streaming tool, where you can capture events and manage your event through Kafka. So Kafka is basically used for real-time, capturing of the events, and also used as like one sort of ingesting from different platforms into a data platform as a tool. Now in Kafka, there may be certain, like about the data streams. So a data engineer should understand like how to create those data streams and all those things. But there may be setting up the infrastructure of Kafka, right? So that may require your infrastructure skills. Even in data engineering, I've seen people like who have not have less or maybe minimal infrastructure skills. So you need Terraform or maybe CloudFormation, that you're setting up the whole infrastructure. Then you may be setting up some sort of networking. So you need people who understand infrastructure. And I would say it's like really, really important when you're designing a data platform or maybe a data product which needs a system underneath. You need a data engineer who has those skills. And if you don't have a data engineers who have infrastructure skills, I think we should bring in the infrastructure, like people, engineers who have infrastructure skills, and they can work with data engineers and maybe share the knowledge so that the infrastructure engineer can in future work on the data things, have an understanding of data things, and similarly data engineers learn that infrastructure skills. So I think apart from that, understanding data streams and all those things, the infrastructure skills are really, really important. And then when we come to the transformation, that's the same thing I've seen. Like, so there are three types of skills I would divide it into. One is like setting up the whole orchestration framework or maybe that distribution system. So you would need a person who understands infrastructure. But then at the same time, you'll be writing certain code, right? Writing some transformations query. So there may be, like when we talk about writing transformations, so that need like understanding of maybe languages like Python or SQL or anything, right? How do you write a query which is optimized, or how do you interact with a data lake, or how do you interact with a data warehouse? So you need like a person who is a data engineer and understands those things. And even some like data analysts have those sort of like skill set where they understand writing queries or maybe some sort of Python code which can interact with data warehouses. Now, what the lack, not the lack, but I think still evolving is the part which is still evolving is the code practices, right? How in software engineering, we do test-driven development. We write tests first, it fails, and then we write the code, right? Or we write unit tests in general as well. But I've seen that in the data world, this practice is still evolving, because I think the two fields still now were working very separately, and data engineers did not have an idea of writing the test driven development and all those things. So I would say that a data engineer, when writing transformation, should understand test driven development, should have like the skills which a software engineer have about writing tests, creating CI/CD pipeline, because still relevant, right? If you don't have it, you'll not be able to deploy properly. You'll not be able to continuously deploy. All those skill set apart from like data is really, really important. And in the right side, like understanding the dashboards or is really, really important for, and there are multiple sort of, dashboarding tools available, analysis tool available like notebooks. So I think having that skill set is also important. I think I'm saying so many things, Raji. I forgot what was your question.
No. My question, you answered my question very well. I was just asking, what sort of engineering skills do you need across those three pillars of data engineering? Very interesting. And like you seem very passionate about the topic as well. So Harmeet, what's been your career trajectory into data engineering? So as a lead data engineer, what is one, so yours would be one pathway and there would be people who have come in from different paths, right? So what is your path into data engineering?
Yeah. So, I mean, I think when I started my career, probably there was no occupation or something like
no titles called as data engineer, right?
Yeah. So I was like a typical software engineer. So I used to work on like databases, DB2. I used to work on COBOL and mainframe as well, and a bit of Java experience, but core was like DB2, COBOL, and mainframe when I started my career. But then gradually, things change. You get to work on. But I was a software engineer, so I kept working on application with different languages and all those things. Then I think when I think about my career, I fell into data engineering. The way I fell into data engineering was, uh, I don't even remember. It was like maybe 7-8 years back. Things were picking up in data. Everyone was trying to analyze, the sentiments and all those things. So I was working on an application, customer facing application, and somebody suggested, why don't we analyze, how programmatically analyze how customers are feeling. So I got interested. I volunteered for that was kind of a side project in the application, sort of ad hoc thing. I volunteered, I grabbed some data. I learned Python. I didn't know Python at that time, but now, like, I feel Python is my core language. So I learned Python on my own, did that analysis, and created some created some projections and showed them, that's how customers feel. And that was the beginning. And I kept doing more and more of that. And apart from this, out of curiosity, so this happened for a while, and out of curiosity, that time I think cloud was not that popular, but out of curiosity I started looking into AWS. And my way of learning is doing certifications, because if I have a target in my mind, I learn well.
So I'm on page with you. I'm the same.
Exactly. So it's a bit tough for me to do random reading. So I created a target for myself that I'm going to complete AWS certification. So I learned AWS and cloud, learned more about that, and combining those two skill set. I think I got a project where they needed that, and then then rest is history. I realized that I'm doing what I was doing just for a dog basis or my curiosity. I started doing it full time. And that's what I've been doing.
So you made it happen for yourself, Harmeet.
I think so.
Either way, right?
Yeah, I think so. It was, I would say it's a combination of my curiosity, and things fell into place. And I never hunted for a job which as a data engineer, but I think it's a combination of a lot of things, and probably luck as well.
Luck always, I personally think luck has a part to play no matter what we are doing. So Harmeet, based on your journey, and you would have interacted, obviously you work in that space, so you would know a lot of other engineers and people who work in different roles. If there's someone, so there could be different, I think if I'm not wrong, there's probably universities now having data engineering courses, which was not there possibly when me or you were doing our education. So that's one path for anyone who's starting new. And AI, ML is such a buzzword that everybody wants to either get into AI, ML, or I think cybersecurity. That's like the hot topics. So other than people who've done education in data engineering, if someone wants to move into data engineering space, what sort of skills? You did mention that you need software engineering, as it's better to have software engineering as a background. And from what you said, I picked up Python as well, that it's good to know Python. I've personally heard a lot of people talk about Python, that if you want to get into artificial intelligence, machine learning, what sort of other skills can people develop? Any specific learnings, courses, certifications that if I am listening and I want to get into this space, what are the key things you said, learn and then see how it goes?
Yeah. So again, it depends on the learning style, but there are a lot of courses available. Again, I'll keep saying the basic fundamentals of software engineering is really, really critical, whether you want to be a data scientist, data engineer, or data analyst, whatever you want to understand those core principles. But then if you want to be a data scientist, read a statistics book as well. Don't feel that it's a cool maths book. There are a lot of, I think I have a book somewhere in my shelf as well. It is called Mathematics for Machine Learning. I'll share that book. So there are a lot of books. So I'll recommend, if you want to be a data scientist, read maths. Don't think that you can get away from maths.
Okay.
If you want to be a data scientist. Now, if you want to be a data engineer, I think, again, as I keep repeating software engineering, blah, 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 but it is critical, because I see that's the core thing. But then, there are courses on Data Camp, Udemy, a lot of courses are there. Again, on your learn, it depends on your learning style. There are
Yes.
books as well. There are a lot of good books. I can maybe, I can share some books with you, and then you can share it
That would
with
be awesome. Yes.
the audiences. A lot of books. So if you are a person who love reading books, so book reading, I'll share those books. But apart from it, there are a lot of courses available on Udemy and Data Camp. I think it's one of the, I've seen their videos. It's really good. It's yeah, if your organization have the license or maybe have purchased it for you, you can, a lot of organizations are doing that. So you don't, I've heard it's a bit expensive, but if you get it from your learning budget from your organization, you can use it. So apart from this, target, so if you're a person like me who feel you achieve results when you have targets, it might go for like any cloud certification. Doesn't matter, it's Google, Azure, or anything. There are data engineering certifications that they provide. Now, apart from, it has an advantage, I mean, two advantages. One is you learn cloud, because ultimately, most of the many organizations are on cloud these days.
Yeah,
So
that's
you learn
true.
the cloud, but at the same time, you learn about the data engineering, frameworks and principles as well. So pick anything, they're all good. I don't favor any of the one cloud, but it's awesome. And apart from this, I've seen that there is, Google has like made a lot of machine learning courses free, and on following the same step, I think because of competition, I don't know, AWS has also made some like machine learning courses, the crash courses, free if you want to, specifically you're interested into machine learning. But from the data engineering, I think, yeah, the best would be to do that data camp course, or maybe, do the AWS certification of the data engineering, or maybe Azure or whatever is it. Yeah.
Oh, interesting. You spoke a lot about frameworks. There are different. Are there any standardized frameworks that are that this space follows? Can you name some if there are some?
Yeah. So I think, so again, it's this space is evolving a lot, and the opinions are changing every day based on what industry is learning. But I think from a data, because I'm a data engineer and most of the time I work on data platforms. Now, data platform is a generic term, but it comprises of everything. It may include just a data lake. It may include a way, it may mean that creating a data product, which may include, like, as I said, machine learning, or maybe just sort of data. So when we're talking about that, there is, a new thing that is coming up is data mesh, which talks about not centralizing all data of your organization and making a big monolithic data platform, because the data engineers of that data platform then would be the bottleneck for everything. You'll be dependent. So how you can democratize the data product thinking is what data mesh talks about. So there's recently a book has been released about data mesh, and if so there, it's data mesh is still evolving, and it's a very good framework, very extremely thought through. But there can be a mix of data mesh versus like the traditional way of thinking. That can be that is one way to approach things, because if you're not a very if you're not a large scale enterprise, then there may be certain aspects you may find data mesh taking a bit of time in, like, and you may not have resources, so you can approach like something in a midway. But the crux here is thinking about how you can create a data platform or a data lake or anything, whatever you want to call, in a way that it is democratized. So think of it as every team, every project is a data project. So, democratize your thinking and don't create a monolithic system. So to answer your question about frameworks, there may be tools and techs, thought process, but I think we need to have more of data mesh thinking in the data platform world.
All right. Interesting. I have learned so much today. I had no clue about, like, I've learned new words today, literally. So, Harmeet, what does the future of data engineering look like to you? Where do you see this going? How do you see this evolving?
Yeah. So it's we are in, I feel we are in like really, really interesting, and I feel lucky that I'm in a time where things are evolving. Right now, as I mentioned in the beginning, that we are at a place where software engineering was 15, 20 years back. So it will evolve. There will be easy to, maybe I feel there would be a click. I think nothing probably would be click of button, but probably mature frameworks to create a data platform, or maybe create a data product. And as I say, every team right now, from the DevOps, we talk about DevOps. So we say that every team, you build it, you own it, those
Yeah.
principles, right? Every team maintains their own pipeline. So I feel that the future would look like every team would have their own data products. They'll be like creating their own data products, and every team would be a data team. Like infrastructure person is important in every team. So similar would be for a data engineer, or whatever we want to call. I don't want to go into the names, but it will be a mix of that. And I think tech space is something really I see really interesting, because I see a lot of good open sources coming in and getting mature, and uh, Spark and all started like that. So we have DBT. There's a new tool which is recently they've published the version 1. They were just like, I think, 0.21 version, but recently, and it's very popular. It's empowering data analysts to do queries in more CI/CD form. I mean, they are empowering data analysts to do software engineering style of transformations. So there are a lot of such tools coming in. There are tools coming in for observability. So right now that space is really, I would say, version 0.0001. People are thinking about observability. So I feel that in future, if all these things would be by default, what I'm saying right now would not be relevant like 20 years.
20 years from now.
Yeah. And I think the other aspect is, let's talk about the machine learning part also. So I feel that the data science part, there will be a lot of automation. There will be a lot of, out of the box tools available. But what is not going away is the core software engineering principle. So I keep coming back to it. Yes. So all this, the things of machine learning, a lot of things would be automated, because there are some common problems like face recognition. Everyone is using it. All those things would be there, but the core base would still be there. And apart from this, I think the field of security, asking about data security, GDPR would get mature. People would ask, like right now, people are not asking much of bias and ethics question in data. It is coming up, but I think in 20 years, in future, it'll be by default. People are right now just worry about training a machine learning model. Are they asking question about is your algorithm biased? For example, if you give a machine historical data of doctors, right? Most of the doctors are male, right? So the machine algorithm would be biased, saying that if you're male, your chances of being a doctor is high. So are we, asking those questions? Are we putting tests in our machine learning model to make sure that the models are not biased? You're not being rejected for a job for a particular reason because of your ethnicity, your gender and all those things. So I think these things are coming back, but in 20 years down the line, these would be more mature and people would be more mature.
The things that I observed or have noticed is, some years ago, we used to have a CTO as, at an executive level. Then we saw the emergence of a CISO, that's for security. Now we've seen the emerging of a chief data officer. So, that space, that whole trajectory of your career has also changed, right? So going by what you have just mentioned, this space is probably exploding and will explode more. There'll be more opportunities. So anyone, I think, younger, older, if they're interested, it's probably a really good field if you're interested to work on and try and get into. It's something that I've never worked on. I haven't worked very closely with anyone in this space. So very interesting conversation, very insightful conversation. And, I don't know, I'm putting you in a spot on a recording, but if, later, if someday we want to talk about what you just mentioned at the end, ethics, bias, and how that can evolve, uh, we should have a conversation once again, Harmeet.
Oh,
I
yeah.
would love to have that conversation with you. Love to get your ideas on it. Love to understand what is happening in this field and what else can happen. I'm so glad we have had this conversation.
Oh, thank you so much, Raji. And pleasure is mine. I feel so good that I got an opportunity to share my thoughts, and it was very, very interesting conversation.
Yeah, absolutely. And thank you. I'm very happy you are here, and I'll talk to you soon, Harmeet. I'll let you go. I think you have more work to do.
Thanks,
See ya. Bye.
See ya. Thanks.